All right, so this is the last lesson in this unit, in Unit 7, and it's factoring polynomials with 4 terms. So far we've looked at factoring polynomials with 2 terms, with 3 terms, and now we're going to take a look at 4 terms. So it is possible to factor a polynomial with 4 terms by using a method called grouping. Follow the steps below to factor the given polynomial. This is really similar to how we would group when we factored when a was not equal to 1. So you're going to kind of see the pattern here. So the first thing we do is wrap the first 2 in parentheses and wrap the last 2 in parentheses. So we're going to group these 2. It says group the first 2 terms and the last 2 terms together. Then step 2 says factor out the GCF from each binomial. So the GCF of this first piece is x squared. And the GCF of this second piece, well, 2x and 14, they both don't have an x in common, but you can divide a 2 out of this piece and a 2 out of this piece. So the GCF is 2 for that one. Does kind of look familiar. Now we take out the GCF. So if we divide, if we had 3x cubed and we take away x squared, we have x left. And if we had a 7x squared and we take away x squared, we just have 7 left. Okay, so you're always going to put that GCF here on the outside. Now we're going to put this GCF on the outside here. And what are we left with when we divide out of 2? Well, 2 divided by 2 is 1. And we just have an x left. And then 14 divided by 2 is 7. Do those 2 match? They do. So your answer is x plus 7 and x squared plus 2. So you take one of the matching pieces and then you take whatever is left over and put it in the other parenthesis. So this step down, we've already practiced with factoring. So when it's 4 terms, instead of having to do the x and all that stuff, it's as if you're skipping the first couple steps and you're just taking out the GCF. This is your final answer. Okay, now step 4 says to distribute to check your answer. So if you ever wanted to make sure that you're doing it right on a test, you could always distribute. So remember how to distribute. X times x squared is x cubed. X times 2 is 2x. 7 times x squared is 7x squared, and 7 plus 2 is 14. Remember, we need this to be in standard form. So I'm just going to flip those 2. Remember, standard form says greatest degree to smallest degree. If this is x cubed and this is x to the first and this is x squared, we just need to switch these 2. Now it's in standard form. And does this piece here match this up here? It does. It's what we started with, right? So that's what we want. We want to make sure we got what we started with. That means you did this part right. So let's look at number 1, directions. Factor each polynomial. So the first thing we're going to do is group the first 2 and the last 2, just like this step says up here. Then we're going to factor out the GCF from each binomial. So take the first one. Let's look for the GCF. We have x cubed and then 4x squared. X squared is our GCF. We have 8x and 32. They don't have an x in common, but they have an 8 in common. And then we're going to rewrite that GCF. We're going to move that down to the next line, draw a parenthesis, and then divide x squared out of both of these pieces. So if I had x cubed, I took away x squared, I have x left. If I had 4x squared and I take away x squared, I just have 4 left. Okay, if I have 8x divided by 8, that's just x. Oh yeah, sorry, always put the GCF down here and then start dividing. And then 32 divided by 8 is 4. And remember, another way to check too is if you distribute this back in, you should be getting this term. If you distribute that back in like this, you should be getting that term. If you don't, you did something wrong. Another way to check it, remember if these 2 match, you did it right. So x plus 4 and then x squared plus 8, that's your final answer. You can distribute, I'm not going to, because this is kind of like a really good double check right here. If you got those 2 matching, then you should have totally got this right. It'd be really hard to not get it right if they didn't match. I mean, if they, pretty much if these match, then you did it right. Okay, so number 2, you want you to try that one on your own. And let's start with 3. So we're going to wrap the first 2 in parentheses, the last 2, take out the GCF. So here if we have w cubed and 5w squared, What's the smallest exponent they have in common? W squared. So the GCF is W squared. And then what about the second piece? Well, they don't have a W in common, but we can take out a -8. Now I'm going to take out a negative because both of my terms are negative. So if they're both negative, you're going to take out a -8. Okay. All right, so let's rewrite the GCF down here, W squared. If we had W cubed and we took away W squared, we have W left. If we had 5W squared and we took away W squared, we just have a 5 left. So drop down this GCF and rewrite it again down here, and then write a parenthesis and what's left over. So -8 divided by -8 is a +1, so we just have that W left. And then -40 divided by -8 is a +5. Those two match, which means we did it right. And then we're left with W squared minus 8 after we put the W plus 5 together. Okay, that's your answer. I want you to try number 4. Let's do 5. So what's the GCF of the first two pieces? P to the 5th and P cubed. The smallest of those is our GCF. Remember, it's the biggest number but the smallest variable, because we can take 3 P's out of here, but we can't take 5 P's out of this. It's going to make it negative if we try to take 5 away from it, right? So our GCF here is P cubed. That's our smallest exponent. Our GCF of the second piece is a 2. 2P squared and 12. Well, 2 can go into both of those. Okay, so let's take out P cubed, and what are we left with? P squared, because if we had 5 P's to start with and we took away 3, we have P squared left, minus 6. Our P cubes cancel out. 6P cubed divided by P cubed is just 6, -6, okay? And then if we take out a GCF of 2 here, we're left with, well, -2 divided by +2 is a 1. So we're left with -1P squared, right? And then 12 divided by 2 is +6. Do these two match? They don't. The signs are different. The numbers match, but the signs are different. So take out a -2 instead. Remember, if the signs are different here, that means instead of taking out a +2, we need to take out a -2. So we're going to make that negative, then I'm going to make this negative, and that changes both of these signs. If I make this negative, if I distribute this back in, I still have to get a -2P squared, which means this is a positive, and that other one is a negative. Okay, so now they match. I'm going to take one of those pieces and my leftover pieces, which is P cubed minus 2, and that's my final answer. Okay, I want you guys to try number 6. Number 7, let's look for the GCF of the first piece. Now, this one we're going to say, okay, well, 3 and 21, they have a 3 in common. And then we have x cubed and x squared. What's the smallest variable that they have in common? They have an x squared in common. I can take 2 out of here, and I can also take 2 out of here, right? Okay, my GCF for the second piece, 4 and 28, they have a 4 in common. They both don't have x's, so I cannot take out an x. Okay, so now we're going to rewrite our GCF, and we're going to say what we have left over. So 3 divided by 3 is 1. If I have x cubed and I take away x squared, I just have x left. -21 divided by 3 is -7. And if I had x squared and I took away x squared, I don't have anything left. And then I'm going to rewrite my GCF down here, and I'm going to divide this. So 4x divided by my GCF of 4 is just x. -28 divided by 4 is -7. Do those two match? They do. So we're going to write one of those and then whatever our leftover pieces, which is 3x squared plus 4. Okay, number 8. We're going to take the GCF of the first two. So 2 and 6 have a 2 in common. And then we have y to the 4th and y to the 3rd. Our smallest exponent for these two variables is y to the 3rd. So that's my GCF. And then my GCF here is 7. So I'm going to take out a 7. All right. So I'm going to rewrite the 2y cubed down here. 2 divided by 2 which is just my GCF, right, is 1. And then if I had y to the 4th and I took away y cubed, I just have y left. Negative 6 here divided by 2 is negative 3. And then y cubed divided by y cubed. If I had y cubed, I took away y cubed. I don't have any left. Okay, I'm going to rewrite my GCF of 7. Negative 7 divided by 7 is negative 1. And then we still have that y. So negative 7y divided by 7 is negative y. 21 divided by 7 is a positive 3. Look at the signs. The signs are different. So instead of having this 7 be a positive 7, I have to change it to a negative 7, which means these two signs inside flip as well. Now they match. So we're going to take one of these pieces, the matching pieces, and then one of our leftover pieces on the outside. That's your final answer. Okay, I want you guys to try 9 and 10. Okay, 11. So let's take out the GCF of the first half. So if we have an 8 and a 12, let's just look at the numbers first. 8 and 12 can both go into 4. So my GCF is 4. And then x squared and x, my GCF is the smallest exponent. So the smallest variable. Well, x squared is greater than x, so I'm going to take my x. That's my GCF. Okay, the 2 and the 3 don't have anything in common, but x, y, and y, if you just look at the variables, they both have a y in common, so we're going to take out a y. Okay, so let's rewrite our GCF. So we have 8 divided by 4, which is 2. And then we have x squared divided by x, so if we had x squared and we took away an x, we only have x left. And then if we have 12x divided by 4x, 12 divided by 4 is 3. X divided by x, those cancel out. If we had one and we took one away, we don't have any more. So it's just going to be plus 3. And if we take out a GCF of y here, we're left with 2x plus 3. Do those two match? They do. You're going to take one of those matching pieces and then our leftover pieces, which is 4x plus y. That's your final answer. Okay, number 12. So here let's look at our GCF in the first two. So we have c squared d and 3c squared. We don't have any numbers that we can take out as a GCF, but we have a c squared and a c squared. They both have the same c in common, which is the c squared. So our GCF here is c squared. Notice here again, they both have negatives, so I'm going to take out a negative, but 7 and 21, negative 7, negative 21, I can divide out a negative 7. And then we have d squared and d. I can take out a d. Remember, we always take the lowest exponent, so the lowest variable. So d is smaller than d squared. Okay, so let's rewrite our GCF on the outside of the parentheses and then divide out. So c squared d divided by c squared. Well, the c squareds just cross off, right? So we're just left with d for our first term. And then we have 3c squared divided by c squared. Well, if I have c squared, I take away c squared. There's no c squareds left. I'm just left with a 3 for my second term. Then I'm going to drop down the GCF, negative 7d. What am I left with? Well, negative 7 divided by negative 7 is a positive 1. And then d squared, if I take away a d, I'm just left with d. And then negative 21 divided by negative 7 is a positive 3. And then the d's cancel out. So those two match. That's a good thing. That means that's one part of my answer. And then c squared minus 7d is the last part of my answer. Okay, so try those problems and then raise your hand when you're done.